Hey everybody, welcome to a video of Steam. So in this video, I'll be talking about capacitors. The first thing you might notice is that I'm not using a camera anymore, and that's because I don't have any capacitors handy. So I'll be using this simulation. I'll put the link to the simulation in the comments below so that you can try it on your own. So first, what is a capacitor? Just like in this diagram, a capacitor is basically a sheet of metal or any conductor, and which is separated using some kind of non-conductor, like air in this case. Here on the top, there's a graph which shows the capacitance in picofarads and the stored energy in picojoules. These we're not going to care about right now. I'm using this because you can adjust the separation here, and you can also adjust the plate area. So if we make the plate area very large and the separation a lot, or make the plate area very small and make the separation a very small amount, we can change the capacitance and the stored energy. As you can see, the capacitance is changing as I change the separation. So first, let's try the largest separation and very small plate area. Now, we just charge it using this battery here. We can take this voltmeter here, which is something that measures the amount of charge or the current, and it shows 1.5 volts. Here, we can just keep it like this and it's not going to be affected by anything. And then, in order to power this light bulb, all I have to do is switch it to this one. And as you can see, the light bulb flashed very bright for a very small amount of time. Now, let's try a very small plate separation and a small plate area. Again, the voltage is 1.5 volts, and also the capacitance went to 4.44 picofarads, and the stored energy went to 0.5 picojoules. Also, this configuration had a 0.09 picofarads, and the stored energy was only 0.10 picojoules. So, back to this one. Now, as you can see, the light is basically the same brightness, but it goes out slower. In other words, the capacitor discharges at a slower rate. Now let's try a large plate separation, and a large plate area. So like this. We charge it up. Voltage is 1.5 volts. Capacitance went to 0.35 picofarads, and the stored energy went to 0.4 picojoules. Now we connect it here. The light goes out in a similar fashion to when the separation was small and the plate area was small, and it's the same exact brightness. Now let's make separation small and plate area large. As you can see, the capacitance went up to 1.77 picofarads, and the stored energy is almost at 2 picojoules. But the voltage is still the same. Now, we connect it to the light. As you can see, the light is bright, but it goes out extremely slowly. Let's wait for it to go out. Okay, so now that this has almost zero stored energy, let's investigate other things. So one thing that I tried was I tried turning this capacitor up and then changing the separation or the plate area. And when I did this, I noticed that the voltage got a lot more, on contrary to my belief that the voltage would drop. And also store energy, look at how much it is. It's 39.84 picojoules, it's off the chart already. So then, when we connect it to this light bulb, the light is intensely bright for a short amount of time. So now, if we do this again, and then I changed the separation but not the plate area and found it got to 9.9 picojoules, but then I didn't separate it and shrank the plate area and it only went to 7.97 picojoules. So, I separated the plates and the light was intensely bright for a short amount of time, but still longer than if the plate area was small and the separation was big. So now that we've gotten to know how this capacitor works and what it can do, let's look into the big ideas and see how this actually works. So this is basically what a capacitor is. Now, the thing is, even though this capacitor works, it's not going to function very well. So a better example of a capacitor is this picture here. So basically, these black lines, they're the conductors, and the blue stuff is the non-conductor. So this shape is made in order to maximize the area, the surface area, on which charge can be stored. So in this way, a capacitor like this could store large amounts of energy while having a very small surface area. So, how does this actually work? To understand exactly how a capacitor works, let's look to this analogy. First, let's add a battery to this. Alright, so now that we've gotten this, now let's see how this works. So, when the battery discharges electricity to this capacitor, at first they have equal amounts of charge, both positive and negatives, on both sides. But when the battery charges this capacitor, what happens is the positive side loses its electrons to the negative side, and so the negative side gains its electrons and loses positive particles to the positive side. So now this side will become totally positive and this one will become totally negative. So let's assume that this is a fully charged capacitor and this is a light bulb. So this side is the positive side and that side is the negative side. So what happens is the negative side, electrons flow through the wires to this light bulb and the light bulb turns on. The electrons then continue flowing and enter the positive side. So now the positive side has some electrons. The positive side emits positively charged particles, which go around the other way and get to the negative side. This process repeats until each side they're both like electrically neutral, which means that this side has equal amounts of positive and negative particles, while this also has both positive and negative particles. At that point, this lamp turns off and the capacitor has fully discharged. So, back to this one. So, what happens is basically the exact same thing. This, it gets charged up using by the battery or whatever, and this one is going to be charged one way, and the other side is going to be charged the other way. And And then when it connects to a light bulb or whatever, it's going to emit the energy that it has stored in the form of electricity. In other words, it's going to discharge. And then once it's discharged, it's going to stop discharging because it has no energy to give away anymore, so the light will turn off. And also, farads are basically the amount of charge that this can store, like the picofarads that we saw in that simulation. Those were the amount of charge that this capacitor could store. So, like if I were to separate them or make the area of the plate smaller, then the farads will go down. Now this is time for the question of the day. So, which configuration out of these two, this one or this one, would store the most energy if they were connected to the same exact battery? Leave your answers in the comments below. I'll see you in the next video.